In this video, we're going to look at a couple different ways to calculate the area of a triangle. You almost certainly know the standard formula for the area of a triangle, that it's one half times the base times the height of our triangle. For a triangle like the one shown here on the right side of the screen, it's not exactly clear how we would use this formula to compute the area. The height of this triangle, at least in the way that it's oriented, would be the length of a segment here coming out of angle C, coming down and being perpendicular to the side AB, which we'll call H, but we're really not sure what that length is. We do, however, know that side length C would be the base. So we do know that we have 1/2 times C, at least how we have oriented this, but now we're not quite sure on the height. However, by looking at the left side of our triangle, we might see that the sine of angle A is going to be the height H over side length B. And so we can multiply by side length B on both sides here to get that B times the sine of angle A is equal to H. And so now we can substitute this into our formula here. Instead of the height, we have B times the sine of capital A. And if we wanted to, we could reorder these so that they're in alphabetical order. So we have B times C times the sine of A. And so this formula here gives us a way of finding the sine, or finding the area of this particular triangle. It's going to be 1/2 times side length B times side length C times the sine of angle A. And notice that even though the height is being used to compute this formula, we don't actually need to know the height of the triangle in order to use this formula. What we need to know here is the length of two of the sides, B and C, as well as the sine of the angle between them. We can apply the previous argument to any orientation of the triangle with any of the sides viewed as the base, and by doing it for all three sides, we obtain these three formulas. The area of this triangle could be thought of as 1/2 AB sine of angle C, 1/2 AC sine of angle B, or, as in the example that we looked at, 1/2 BC sine of angle A. In all three cases, notice that we have the 1/2 times the product of two side lengths multiplied by the sine of the angle between the two side lengths. So for an example, suppose we have a triangular plot of land that's bordered by three roads. Two of the roads are going to intersect at a 72-degree angle, and the plot has 147 feet of land along the first road and 207 feet along the second road. And we'd like to find the square footage of the plot. So for example, we might just draw a general triangle here. Looks something like this. This would be our 72-degree angle between our two roads. We have 147 feet along one of those roads and 207 feet along the other. And so in order to use the sine formula for area that we've just seen, we can simply take as our area 1/2 times the product of these side lengths, 147 times 207, as well as the sine of the angle between those two side lengths, which would be sine of 72 degrees. We could simply put all of that into a calculator, and we get that it's approximately 14,470 square feet. Notice here that we don't actually directly find the height of this triangular field. However, of course, the height would be the 147 times the sine of 72 degrees. But the nice thing about this formula is that we don't actually need to find the height separately. We sort of just find it at the same time. And so our area here of our triangular plot is almost 14,500 feet squared. In order to use the sine formula that we just used in the previous example, we do need to know an angle of our triangle as well as the lengths of the two sides that form that angle. However, if we wanted to find the area of a triangle like the one shown here, where we know the three side lengths of 4 inches, 7 inches, and 9 inches, the sine formula won't exactly help us out because we don't know any of our angles. However, there's another approach to finding the area that we can use called Herons Formula, and it deals with the semi-perimeter of the triangle. So the semi-perimeter of a triangle with angles ABC and side lengths lowercase a, b, and c will be the perimeter, which is the sum of a plus b plus c, the three side lengths, all divided by 2. So this is 1/2 times the perimeter of the triangle. So for example, in the triangle shown here, our semi-perimeter S will be 4 plus 7 plus 9, all divided by 2. 4 plus 7 plus 9 being the perimeter of our triangle. That perimeter there is 20 inches. And so dividing that by 2, we see that the semi-perimeter is, for this particular triangle, is 10 inches. The semi-perimeter can then be used to find the area of our triangle using Herons Formula, shown here. The area will be the square root of S, the semi-perimeter, multiplied by S minus A, multiplied by S minus B, multiplied by S minus C. So inside the radical, what we're going to do is just multiply the semi-perimeter with the semi-perimeter minus each of our three side lengths. This formula comes from the sine formula that we've seen previously and the law of cosines, and has an algebraic derivation that would take quite a while to do, but it does follow from those two particular formulas. For an example of how to use Herons formula, let's suppose we have a triangular garden with side lengths of 20 feet, 23 feet, and 27 feet, and the garden needs to be covered in mulch. We'd like to know how much mulch we're going to need in order to do this. In other words, we need to find the square footage of the area of this triangular garden. Since we know the three side lengths of our triangular garden, this sets up perfectly to use Herons formula. Our first step is to find the semi-perimeter. So we add up our three side lengths of our triangle, 20 plus 23 plus 27, and divide that by 2. Our perimeter there looks to be 70, so we have 70 feet divided by 2, so our semi-perimeter will be 35 feet. Now using Herons formula, our area will be the square root of our semi-perimeter, 35. And then the remaining factors will be 35 minus each of our side lengths. So 35 minus 20, 35 minus 23, and 35 minus 27. Of course, this will be 35 times 15 times 12 and times 8. If we multiply everything inside the radical together, this is the square root of 50,400. And to get an exact value, or at least an approximate value here, it looks like about 224.5 square feet. So we're going to need about 225 square feet of mulch in order to cover this triangular garden.